Hello class, this is Paul DeStefano. I'd like to continue with my next lesson on earned value management by building on the lesson that I posted last week on the introduction and practical example. I'll quickly go through that as a reminder before continuing into lesson 2. So in this lesson, we had a software project that was budgeted for $1 million, or basically 12,000 labor hours, which meant our spend plan was 1,000 hours per month, which led us to a spend plan of 84K per month. And I'm going to start trying to equate labor to dollar value in this so that we can see variances and how much they're costing the project rather than just labor hours. So let's move forward here. We said this was the first month's EVM report, and we spent 84K, which is 8.3% of the total $1 million budget, since 8.3% is 1/12, and this is basically 1 month out of the year, so we were right on the spend plan. But we also talked about the fact that we had no way of knowing whether we were making progress by spending 84K per the plan. So we decided we needed to create a plan and set up the work breakdown structure, and then create a schedule to lay out when and by whom these tasks will be completed, and apply a budget to each task. And of course it will match the spend plan. So for the first month we had 1,000 hours of activity planned, as the third bullet indicates, and the tasks that were to be performed were the 5 tasks shown up above that. And we knew we spent 1,000 hours, but we didn't necessarily know whether we had completed these tasks for the hours that are allocated for each task. So we laid out the project progress, and we showed the planned value for each, the 200, the 60, the 240, which matches how we laid it out in the integrated master schedule, the IMS, which is based on the WBS, which is the work breakdown schedule. And then we showed what we completed percentage-wise of each increment, and the earned value associated with that based on the percentage and the actual cost. So we planned 1,000 hours, we earned 804, and we spent 1,020 hours in labor to get those tasks done. And below that, we basically showed the spend to plan was right on 1,020 out of 1,000, and we showed the CPI, SPI, but I'm going to go into more detail now in lesson 2, common EVM formulae and the application of those formulas. And I'll repeat the cost variance, the schedule variance, and CPI and SPI measurements. So basically, the common EVM formulae is the planned value, which we've already studied, meaning that is how much value you've assigned to each task from the WBS and scheduled it as to when it would be completed. In the previous example, the planned value for the whole first month is 1,000 hours. And then you have the earned value, which is basically how much of that you actually earned by completing those tasks. And in that example, it's the work actually performed, as I said. And in that example, we earned 804 hours for the first month of work. And the reason I'm doing this for the first month of work, because that's typically the reporting period on earned value, either to the corporate executive management or to the customer, or both. So we're doing this based on the first month's report. So the actual cost is the total cost incurred for the work performed. And in the previous example, the actual cost was 1,020 hours for the first month. So those are the 3 primary data points: is the planned value, the earned value, and the actual cost. So then we start performing calculations based on that. And as you can see, cost variance indicates whether the project is under or over budget at a specific point in time, in this case the end of the first month. So the cost variance equals the earned value minus the actual cost. So our earned value was 804, actual cost was 1,020. So in accounting terms, with parentheses being negative, we are minus 216 hours cost variance. And at the $90 per hour that we showed in lesson 1, that equals 19.4K negative cost variance, which obviously is not good already in your first month in the $1 million budget. And then the schedule variance indicates whether the project is ahead of or behind schedule. And so schedule variance equals earned value minus planned value. So 804 minus 1,000 equals negative 196 hours. And that times our labor rate of $90 per hour equals minus 17.6K schedule variance. So as you can see, cost variance dollars and schedule variance dollars are not necessarily equal because there are a different number of hours that you're over budget and behind schedule. So that is how that calculation is done for cost variance and schedule variance. Then we get into some very important forward-looking metrics that are going to help you project what's going to happen at the end of this project if we continue at the current rate and current efficiency. So we measure cost performance index, which is used to measure the cost efficiency of the work completed. In other words, it's work out over work in. So we get CPI equals earned value divided by the actuals. So we earned 804 hours, but we spent 1,020. So that's output over input, just like the efficiency of anything you would measure would be output over input. And that equals a ratio of 0.79, which is a 79% cost performance index. And then, as we calculated earlier, the schedule performance index measures the schedule efficiency. So the SPI equals earned value divided by planned value. So you get 804 hours divided by 1,000. So you have a 0.8 schedule performance index. Now those numbers, I will tell you from experience, are considered low. Anything below 0.9 is considered red and needs immediate corrective action, so you don't continue in that mode and basically spend all your budget without getting the work scope done. So what we can use those numbers for, which is interesting, is to schedule or calculate the estimate at completion, which means if we continued in the current mode of 0.79 and 0.8, our estimate at completion would be this number right here, the budgeted completion, which is the $1 million that we talked about in the first lesson, divided by 0.79 efficiency, means our dollars value for estimated completion is going to be 1.265 million. So that's not good because our budget's only $1 million, and with a 79% efficiency, we would potentially run $1.265 million on a $1 million budget. So then the variance at completion is forecast the difference between the budget at completion and the expected total cost. So you get budget at completion minus the EAC, you get 1 million minus the 1,265, and you can see the variance at completion right now is projected to be $265,000 negative. So if we continue in the current mode, we would basically spend $265,000 more than our budget. So that's how these calculations are made, and these, like I said, are the most common EVM formulas and what they mean. In next week's lesson, I'm going to talk about corrective action and what you would do with these numbers, because it's great to collect data, it's great to make measurements and create metrics, but it's pointless unless you're actually going to do something about it to try to correct it, to get the CPI up, get the SPI up, and get back on plan. And using this data, there are certain things that it tells you, and I'll go through even other scenarios of what happens if CPI is high and SPI is low, or CPI is low and SPI is high, or they're both low or they're both high, and what that's basically telling you, the types of corrective action you can put in place to try to get back on plan. So thank you very much, and I appreciate you listening to this lesson. And if you have any questions, please contact me on the general discussion board so that everybody can benefit from whatever question you have and whatever answer I can provide. Thank you, and have a great week.